Jeff did a pretty nice demo of his robot this week. That was exciting to see. I've been up at InfoAg this week, so trying to learn more about precision agriculture and how robots fit into that picture.
How do you like it there at InfoAg? Have you seen something fun, interesting?
Yeah, there's a lot of talk around precision agriculture and like variable planting, variable spraying, and trying to. It doesn't seem like they thought there was going to be big yield increases and money out of that, and that hasn't really panned out. Today there was a long session on robotics, so Kyler presented today, did a great job. It was fun seeing the work that he's doing. Smart Ag presented. They've got an autonomy kit. Looks like they'll be on the market maybe next year. Automated dairy farms. Dairy farms are extremely impressive, fully automated systems. So big future of robots in agriculture.
Sounds fun. I knew Kyler was presenting. We had a talk about it last week or this week. I don't remember anymore. Yeah, pretty cool.
I'm going to give a talk on ROS agriculture tomorrow, or leveraging the power of ROS for robots. So if people are interested in what ROS agriculture is doing and what ROS is.
Yeah, hopefully we can get some people involved with lawn tractor. That would be cool.
Matt, I'd seen just recently you had a little diagram flow chart of the control system on the lawnmower.
Yep.
And I see that the Teensy was in the middle of it, so I had to start doing some research on what capabilities the Teensy had that the Arduinos didn't. Is there any other significance of using the Teensy in there versus at what point would not, say, the Raspberry Pi 3 handle what the lawnmower would be needing?
They serve kind of two purposes. The microcontroller, the Teensy, has the I/O, so it has the PWM outs, and you can read analog signals, and so it does the low-level processing, motor controller and reading senses.
And the Raspberry Pi would be overtaxed, or it just doesn't have some of those capabilities?
Yeah, it doesn't have those capabilities, and it runs kind of like the higher level software that processes that data. I mean, it has some of the capabilities through the GPIO, but you'll want to use a microcontroller. Generally that's how it's paired.
Also, it helps to isolate different components and different systems from, just making a system standalone would mean it would be less risky in terms of just, a system failing. If a Raspberry Pi is out, everything's out. Well, Raspberry Pi runs ROS, so if it's out, everything is supposed to be out, but it also helps with fault analysis and other things. So if they do come up with a Raspberry Pi with all the I/O, it would be, in my opinion, to just have some systems isolated in a way that they perform their functions with microcontrollers, and you just relay back the information to the Raspberry Pi, making the system more reliable. It's kind of weird in terms of the definition of reliability, because the more the more components you put in, the more or the less reliable the system gets. But in my opinion, the benefits of having different isolated systems outweigh the benefit of having one central system in this case.
You can definitely make a robot with just the Raspberry Pi with the GPIOs, but a really kind of a small, lightweight robot.
A lot of these autonomous drones or drone boards these days have everything on board, and they don't even go with GPIO. They just put it all on just one chip. They make a hat. And you must have seen the early brain and the other ones. I can share the links. And these things are, oops. Okay. These have everything on board, everything soldered on board. The GPS unit, or you just have to connect a GPS antenna on top of it, and it comes with a gyroscope and an accelerometer and a magnetometer. So the IMU is on board as well. And you can hook up a Pi camera to the Raspberry Pi, and now you have it's a system that's just one board. That's such a small system. These work really well, and you connect. They also come with motor drivers and everything on board. So all you have to do is plug in your BLDC motors, and you're good to go. You need a frame and some motors and some rotors, and put this thing on, and connect everything, and off you fly. It's pretty cool.
Matt, did you get a chance to do anything more with that Intel T265 or whatever it was?
I haven't. I did bring it with me in case I wanted to play around with it, but I need to put it on the robot and then match it with the GPS. That would be the next test.
Yeah, I did some sort of study on it when you brought it up, and yeah, it's certainly got some promise, hasn't it?
Yes. Yep.
One of the things that we're looking at is one of the guys is working on fusing 4 cameras so we can get a safety perimeter around the vehicle. So we're only looking for humans at this stage. And I think he was doing that with a different type of RealSense. I think it was a cheaper one, earlier version. And that shows some good promise from a safety point of view, and also I think by having four cameras there, we may be okay in the redundancy type scenario. But that doesn't help us with what we want to do in regard to SLAM if we lose the GPS. And I was thinking that 265 could assist us with that. So we need to do some more determination on. I think one of the problems that we're going to have is that if we lose RTK, if we rely on our heading, that's all well and good, I think. But if we only have 2 points down a row with a row of vines, and there's something untoward in the middle of that, we've got to negotiate around that. So I think that's where the SRAM would come into it.
It's definitely nice to have, makes your system a lot more robust to have. You're going to have your wheel encoders and different estimates, but having visual odometry all built on one system already ready for you with a ROS driver already done is a nice advantage.
Yeah, for sure.
And for $200, a complete package is pretty good.
Yeah, that's one of the things I was saying a little while ago is as soon as you determine that you're going to use one product, they bring out a better one.
Yes.
It's a little frustrating, but it's okay. It's better that than the alternative, which is they don't bring out a better one.
Yeah, nothing comes out. Yeah, I think that for the transition, I mean, in and out of GPS or handling GPS hops or outages, I tried to run through a vineyard and the headland was about 18 feet, but there was a row of trees at the end. And we'd come out of the rows and then the GPS we would lose RTK. And then at that point, if you're in float, maybe, but you don't really know where you are. So having some other system, really important.
Yeah, that was identical to what we were finding. So we'd go down the road, as you say, our headland there was probably about probably 30 foot, but we didn't want to skid steer, do a skid steer turn because of the amount of damage that we do to the headland. So we wanted to make a gentle turn, which was like using about 7 meters of that headland. And then occasionally, because of the trees there, occasionally we would go into float, which was not good. So we want to, the funny thing is that we would go into float, so we would stop the vehicle immediately. But then 4 or 5 seconds later, we'd get it back. It's the machine's in exactly the identical position that it stopped in, or give or take maybe 200 mil or so. But yet we would regain RTK. So we'd get the RTK back and off we'd go again. It was kind of crazy. So I don't understand why we would lose it. Obviously there's trees there and everything like that, but they're not. I would have thought that if it was shaded from the trees, then we wouldn't get it back until we moved to a different position. But yeah, so it's the case that we have to have that backup system where we can continue to run for a period of time to allow the RTK to come back.
I've done a lot of testing in orchards and with radios and GPS, and it's really strange how the signals bounce around in there. It doesn't make sense sometimes. Sorry, there was, speaking of trying to get signals inside of orchards, that's extremely difficult. RF just gets eaten by fruit and trees and branches. But today Microsoft was talking about using TV channels that weren't in use to broadcast. So they have a tri-band radio using VHF, UHF, and 900 megahertz. And they're getting really good bandwidth and distance. You can get really good distance with those big waves. I don't know if it's on the market yet, but they called it white band TV. So that's pretty exciting.
So that jumping from GPS to onboard processors for navigation, is that somebody in ROS already have packages that does that pretty seamlessly, or is the robot right now going to struggle when it loses an RTK while it switches to another system to try and keep going?
Yeah, the package is called Robot Localization, and that one, it fuses all of your localization data together. And then as your GPS, let's say your GPS drops out of fix, there's a message in your GPS signal called a covariance, which is kind of like your estimate of error, square root of error. But that will get bigger if you drop out of RTK. And then, so that measurement, your GPS measurement, will be like integrated less, than your other sensor, your onboard sensor, like if you use visual odometry. So it kind of compares all of your sensors and then your error estimate to give you your localization. Still complicated package. Robot localization is complicated, but that's how it kind of does it.
So like Walter was saying, with more cameras, how much more processing power, when does a person be concerned with onboard processing power, or can some of that be localized and given to ROS in that regard where, like we were saying earlier, separate some of the processing? Can all your cameras be on one system and then they talk to ROS and that fusion takes place within the ROS localization?
I'm not sure how Walter's setup is, but you can, so for example, on that RealSense, the T, that 265, it has the processing power on the camera. And so it can give you that pre-processed data. So, but if you're reading in raw camera data, then your onboard computer would need to do visual odometry on that and then send. The output of visual odometry is an odometry estimate message, and then that goes into robot localization. You just add a bigger computer or add another computer.
So what we're doing, Jim, is that that camera setup is strictly for safety. So we have our own, or we have a processor that is doing strictly safety again. So all that computing power is tied up in that one processor. So that in that we'll have a couple of bump stops and e-stop, and that will form the basis of the safety system. And then we just have basically one output there that will shut down all the implements, shut down the hydraulics, and then we'll be monitoring things like wheel speed and stuff like that. And if we don't see that we're at 0 speed, then we'll shut down the diesel as well. So it's just an ongoing, how far do you go with it? It's we got to try to take every reasonable thing into it. I mean, the thing is that we want to sell these things as well. That's our goal, and that's going to be difficult with all the safety regimes that we have to put in place.
So I was looking at Jeff's robot this week in his demo. A couple of things I thought was pretty awesome about his robot is the light indicators that he has. I think it's really well laid out, well designed. So he knows what state the robot is. Jeff, I was wondering like when you remove that e-stop, that light goes green, but do you have like a startup sequence with the LEDs, or what are the status messages that are information is coming off of your robot?
Right at the moment, I've got on the back, I've got that e-stop switch, and there's just a LED, a red-green LED tied directly to it. So it's just a mechanical or just a straight electrical connection. So if the e-stop is pushed in, it's red, and if it's pulled out, it's green. And the main reason for that is because we've had situations where, you know, you got your thing all set up, you're trying to run it, and you say go, and it just sits there looking stupid. And nobody knows why. So you have to run around all the switches and check them all, and you have to check all the conditions. So it's nice to have on each e-stop switch just have a physical indicator there, so you know if it's active or not. So then I carried that through to my remote control receiver, where there it's got the from the remote control receiver, it runs the e-stop relay. And that relays in series with the main e-stop switch. So I added a red-green LED to that board also. So if you're carrying the remote around and you push the e-stop on that, then the LED turns red on the robots, you know, that one's active. But still, just because one of those is active, you don't really know what's going on. And that's where I was going to use the beacon on the top, where I can turn that multiple colors. And I figure I've only thought of 3 colors so far, because, you know, normal commercial vehicles, when you're driving around, it's got an orange flashing light on the top. And then somewhere I read that, or somebody told us that if it's an autonomous vehicle, when it's driving around, that should be a blue flashing light. So I've got orange and blue taken up already. And then I figure red would be an error indication. So say it's driving around and hit the remote e-stop, then the beacon on top would turn red, and it could either be a flashing red or it could flash some kind of a code or something. So that right there is just the beacon's the main thing, just to give you an indication of what it's trying to do at the time. So for instance, I powered up, and if any of the e-stops are pressed, then it's not going to move, and I could have the beacon on the top flashing red, so you know that, so you can walk around. And actually, the other thing we were talking about the other day was, say, the red would indicate some kind of an error condition. And then you could also have a thing where you could have it so it'd count up a number, so it'd flash once or twice or 5 times. And then you'd have a little chart written down that says if the error code of 5, that means, say, your GPS is not working, or error code of 3 could be loss of communication somewhere. And maybe just an error code of 1 says you've got an e-stop active. Then you have to run around and look at your LEDs and figure out which switch to turn back on. So say you power it up and you release all your e-stops, and then it goes into, I'm thinking it'd go to an orange condition, and maybe have a slow flashing, which indicates you're communicating to the remote control, but there's no movement. And as soon as you move a joystick, it can switch to a fast flashing orange indicator, just so you know that the thing is attempting to move or going to move. And then from the remote control, the way we did our original system, we had a switch on there that was either autonomous mode or not. So you could be driving around with the remote control, and then you flip the switch up to put it into autonomous mode. That instructs the computer it can go ahead and start driving the thing around. And then I figure at that point, so the position of that switch, if I put that into the autonomous mode, then the light will go into the blue mode and either put out just, you know, either a flashing blue or a solid blue, or again, count out codes depending on what you're trying to do. So that's just kind of a universal type thing to show you what's going on. And I've got another base color. I still got green that I haven't figured out what to do with. So there may be something I could do with the green. And since it's an RGB LED in there, I can get like 7 different colors on that. Plus I got the orange LED, which is a separate one. So I got lots of different colors I can play with. And it's just a matter of determining, you know, what do I want these to do? And I purposely tied that into my low-level computer, simply because the same reason I used my remote control is tied into that. So I can walk up and turn on the main power switch and immediately start driving with the remote control without having to start up my Linux computer or my ROS or anything else at that point. You know, I'm in manual control at that point. And then also, since any of my indicators are going to be tied into that computer, you know, once I turn the power switch on, if it decides to display an error condition, it can do that. And then still, once I start up ROS, if it says, oh, I've got an error I want to display, it can send a message down to that board, so I can have either computer could be generating patterns to put up on that display. And then the other thing we talked about at the last meeting, I think it was the lawn tractor meeting, we were talking about this, And I was pointing out you can get those addressable LED strips, and you can just buy a roll of that and cut off however many you want, and hook that up to a microcontroller somewhere. And again, you can just either have a ROS command, or again, I tied it into my low-level one, so it would be in actual control of those. And if I wanted to send a message down from ROS, I can do that. So in that case, you can just say for instance, you cut off 10 LEDs, and you put that strip across your vehicle, and then you would just have some code somewhere that says, I want LED number 1 to be this color, and I either want it to flash or fade up and down or whatever. So you can just basically on the fly determine what you want these things to do. So we were saying that, what do you do with those? And I could say have the first LED on the left could be my indicator saying whether my cell modem is connected to the internet. So it could be, if there's no connection, it'll be off. If it says it's connected to the internet, maybe I can ping Google or whatever. It would turn on a different color, or turn on some random color that I pick. And then if I get connected to the correction server for my GPS, then it would turn a different color. So I would know if I have correction data coming in. And then you can, and the other thought is, when you pick colors for that, try to figure out some kind of a rainbow effect where you say, this is the darkest color or the lowest color. And then as you move up, maybe white would be the highest color, the highest priority color. So just have like a rainbow pattern that you define ahead of time. So when you look at it, you say, oh, that's kind of in the middle of my pattern. That's so you can it kind of reminds you what you're trying to do at that point. So then, since you got so many LEDs across there, I could take my second LED, and that'll be a GPS receiver. And again, if that's not on at all, I'm not talking to my GPS at all. And if I'm getting a signal and I'm getting, say, a single point fix, it could be one color. And then if it's say a float fix, it could be another color. If it's RGK fix, it would be another color. And then you could have another LED that might represent like signal strength from that. So either a number of satellites, you might get your brighter color, or the horizontal dilution or precision. And basically you can just assign these on the fly. You just, whatever you can think up, you just pick an LED and say, I want to assign this kind of information to it. And then you could take whatever LEDs are left over, you can make that into a bar graph if you wanted to. So you can say, here's the bar graph representing motor speed, or here's based on the heading we're going, you can have it change. Or like the, what are they called? The ROS GPS. I can't remember what that group's called. The group that's on the Combine forum that's doing the autonomous vehicles. On their screen, they've got like a screen that runs on a laptop PC that shows what's going on. And across the top, they got their light bar. And the light bar tells you your, essentially, I think you can program it to say, here's how far off we are from center. So they had like one indicator in the middle that was yellow. And if it turns to the right, or the numbers go to the right, I think it would get red, and have it would have like a bar chart that, have a bar chart that extends out this way that's red, so they get more and more red LEDs. Or if it goes this way, they'd be green as it goes out. And if it's right in the middle, you just have the yellow LED on. So you could use that for a couple of things. One, to say, here's an error condition of how far off from center I am. Or you could program it, say, based on what I'm sending for my steering command, you could also do the same type of thing with that. So just by having this simple, cheap LED strip, because it just takes a strip of LEDs and one of the little Arduino boards. And if you wanted to, you could use the USB port on that, plug it into your big computer. So you could have your ROS computer sending out any combination of messages you want, or I can plug into my low-level computer. And then again, that can just send out messages to the Arduino and tell it which LEDs to turn on. And you can have all these program patterns, make it fade up and down or fade back and forth, or whatever you want to do. So it's just some of the stuff I'm thinking about right now, and I just need to get the time to implement it.
Do you think that would be good to, like, you mentioned those ROS topics, but to integrate with the diagnostic aggregator, like if we had 5 standard things that ROS was checking with the aggregator, and then it could display on the LEDs or the lights?
Yeah, you could just have a node that says subscribe to the diagnostics, and then in your little thing, you'd say, okay, I want to take the first diagnostic error and I want to assign this color to it, and then you'd publish to your thing that's talking to your LED strip. So somewhere there you have a configuration file that says LED number 5 is going to be, I can't even think what the error is going to be. Say you're too far off path. What Al keeps talking about, the cross-track error. If that gets too big, then maybe you want to indicate that on one of the LEDs, have that come on so you know that that's what's happening. But by doing that, you've got a lot of information you can display there without having to pull up a laptop and try to read it in the sun. If people haven't tried that yet, you take your laptop outside and it's almost impossible to see what your laptop says. So it's nice to have some bright LEDs lighting up. Or if you really got ambitious, you could even have it talk to you because of the computers. You know, you got a Linux computer, you can put a speaker on it, and you could actually have a voice talking to it if you wanted to. That'd be another way to do it. Or use the Bluetooth and have Bluetooth headphones so you could actually, you can have the computer talking and then you can hear it over your headphones to hear what's going on. And I think as you play with the stuff more, you start realizing, boy, it'd be handy if I had a better way to control this as opposed to having to start up this script, start up that script, go change this parameter file. And you do all this screwing around and you still, then once it starts moving, you still don't know what it's doing because you don't have any information coming back. So I think eventually, as people look at this, they'll come up with better ways to program that in. So if you would say, I want to run demo number 3, you could have something on, say, on my case, I got the remote control. I could have like an up and a down button, so I could just scroll the LEDs back and forth to say, this is the test that I'm going to run. So I scrolled over to LED number 3, and then I hit my autonomous switch on, and it would start running that path, for instance. Or like say you have it out in your field, or say in the morning you start it up and say, I want this to automatically drive out to my vineyard. So you hit the button and say, go over to test number 4, which is drive out to the vineyard, and you say go, and then it knows how to drive out there, and you can have the other indicators showing you what's going on as far as, if it's on path or not on path, and your other LEDs telling you if your GPS is running or not. And like you were talking about, if the GPS drops out, you switch to your camera, you switch to your IMU, you can have all those different indicators saying, what is it using at this point? Or say you have one that's specifically for IMU. If you decide that you're trying to pick up a magnetic heading and it doesn't seem to agree with everybody else, and that indicator can turn red. Otherwise, it could be green, or green is good and red is bad, and then somewhere in between could be, it's starting to get questionable or whatever. So for each type of sensor, you could have one LED assigned to it, and then figure out what colors you want it to light up. So it's just a matter of playing with it, I think. Once you get it so you can display this stuff, then you just have to make up a list of things you want it to do, and start thinking about, now if I took it out there and it's running wild and I don't know why, you want to be able to look at the LEDs and see what they're doing at that point. And then if it gets bad enough, comes with a big enough error, you can have the thing actually stop and then start flashing your beacon on the top, so you know that you've got an error, and if it's flashing out of code, you'll know why.
It's smart. It saves the troubleshooting and that unknown of what's going on in the robot. You're getting feedback directly from the robot.
And along those lines, it's always good to have log files too. So after the fact, you can find out why exactly it went down this path and finally decided that it had to shut itself down. You might be able to play back the files and see what the thing was doing at the time. Did it lose its GPS first, or did it lose its magnetic heading, or did it hit a bump in the ground, or did somebody walk out in front of it? So that's always good to go back and track that stuff down.
What sort of communication would you have driving the LED driver from the computer?
On my beacon on the top, I'm just going to have I/O pins. Well, actually, I bought that little PWM board from Adafruit. I think it's a 16-channel PWM, and you talk to it over an I2C interface. So it's like it's a 2-wire interface plus power and ground back to my microcontroller board that's sitting right next to it. And I say, go out to channel number 3 and set that to 50% PWM. So then the output pin from that, I'm going to run out to a power driver, and that'll drive, say, my red LED, and then another one to drive my green LED, one to drive my orange LED, and so forth. And so then in my code, I'm just going to have something that you would have a function that says, I just have a function called beacon, and then as parameters, I'd say number 1 might be the color I want it to be, number 2 might be the pattern that I want it to do, And since I can control the PWM from 0 to 100%, I was also think about putting an ambient light sensor on top of the thing. So if you're out in the sun, it says, oh, it's really bright, and it's going to crank the power up all the way, so you're going to get 100%. And if you're inside of an office, like I brought it in, it's sitting right over here on the floor next to me right now. So if you take it in somewhere like this and you crank it up with full power LEDs, boy, people are going to complain really quick. So it's nice that it knows that it's not as bright, and it can crank it down to, say, 50% intensity. So one of the fields on that could then be the intensity you want to run at, or that might just be built into the, the overall driver that runs the thing. So basically at that point, it's just a function in my main microcontroller. I just call that and say, I want this color, this kind of pattern, and this intensity, and it'll go ahead and do that for me. As far as the LED strip, that one, where you just hook an LED strip up, you can just get those little Arduinos that are about this big, the little $3 boards or $5 boards, whatever they are. And it's just it takes one wire to drive it, and then you need power and ground on the strip to make it light up. And once you got that on the Arduino, you got the little like a USB connector, and you can plug that right in. If you're running a laptop to control it, or a Raspberry Pi, you can plug it directly into that and just have Arduino code that says, go to LED number 3 and set it to this color and this intensity. So it's basically going to work the same way as the beacon does. Just you're gonna have a lot more LEDs on it. And then in my case, since if I do that, I'm going to tie it to my low-level controller, so it's actually in control. And if the Raspberry Pi or the Linux computer wants to put something, it would send a message down to this board, and then the board would pass that on. So you could allocate. Some of the LEDs are Linux, some of the LEDs are the low-level controller. And again, that's just up to you how you want to do that. But I think as far as the physical interface, it gets down to the point you give it power and you give it a USB cable, and then you just write up a little thing that says, I'm going to send it this command. It's just going to be just like the functions on that, or the parameters on that function. If you're doing it over USB, you would just say, send out a message that says LED number 1, this color, this intensity, and this pattern or whatever. And so it's just a matter of then you write up whatever code you want to generate those little messages to turn it on and off. And once you get to that point, I said, I had to add CAN because Danfoss does everything in CAN. If you get the right little microcontroller board that's got a CAN interface, you could even send it CAN messages if you wanted to. So like here, if I wanted to put on a big tractor here and I just want to put some status information on, I could just plug that right into our CAN bus, and then our little Danfoss controller that talks over CAN, I can just go in there and say, talk to the LED strip at this CAN ID, and again, pick the LED and the color and the intensity and so forth. So there's various ways to do it. It's just the physical pieces are the LED strip and the little controller board, and then it's up to you to decide, how you actually want to talk to it, because all the interfaces are on there, and you're going to program it with the Arduino IDE. So you just say, take the serial data coming in off the USB port and turn on these LEDs, and that's how you would go about doing that. Does that make sense?
Yeah, the Arduino IDE side of it does. I still haven't quite pictured then how ROS would be in the equation. Where would you even bother bringing that information through ROS? Or if ROS wanted to generate a signal coming out, how do you get that to a serial communication for your Arduino or your Raspberry to forward along?
Well, if you want something in ROS to do something for you, you write what's called a ROS bridge. And so basically you write just a little piece of software that says, subscribe to this topic. So if you're going to make up a topic, before we talked about if we're going to take the diagnostic aggregator and have it turn lights on and off. So there you could have one node that subscribes to the diagnostic messages and creates a topic. We'll just call it LEDs or LED status or something. So it's going to be publishing on LED status. So you could write another node that's going to talk to LED strips, and it's going to say subscribe to the LED status. And then on the other side, it's going to say connect to the USB port, COM, whatever. And you just generate your message there, and it just spits it out the serial port. And then it would show up in your Arduino, and you would magically turn your LEDs on. So it's just a matter of again, it's on the Linux side, you just have something that subscribes your ROS topics and then sends whatever command you want out that your Arduino can understand. So you just have to get those two to agree on whatever your command protocol is you're doing. And the other thing I talked about where I said I'm going to have my Linux machine running, and if it wants to send information down to the LEDs, I already have an interface between the Linux machine and my low-level microcontroller, which is probably going to be a USB cable, and I just send various commands over there. I send down speed commands, and I send down whatever commands I want. I can read back velocities and positions, but I could also have just define an LED status command. So I just package the stuff up and send that down to my low-level microcontroller. It says, oh, I just got a LED status command, so it knows to strip off the right numbers, then pass it to that function I said would turn on either my beacon or my LED strip. So it's really just a matter of just moving stuff around and getting it all to agree when it talks back and forth.
Another way to do that would be ROS serial. An Arduino would just simply listen to the ROS messages that are being sent over and then act accordingly. So then you don't have to do anything on the Linux side. You just have ROS just, so each of your sensor nodes would be sending out warns or ROS log or ROS warn, basically debug errors and, debug messages or error messages, and on the other side, the Arduino would just be listening to those, and if it finds something, then it would just turn the LEDs on. That way you can just avoid writing commands from Linux to the microcontroller.
Yes, this ROS serial concept is a way to get data from your Linux machine down to your microcontroller. And it's a standardized thing you can just load up and drop on there. And so far, I have not used that, and I just choose to write my own command protocol between the two. So I just, on the Linux side, I subscribe to something and strip the numbers I want and just shove them down to my microcontroller, which is running a bunch of other things at the same time. If you can get everything to run, if you get everything to coexist with this ROS serial, that'd probably be a good way to go. Because once you load that on your board, then right in your, down at the Arduino level, you say, tell your program to subscribe to this topic called LED status, and it just magically gets pushed down from ROS down to your microcontroller.
I had one other question on your remote control. What did you determine was the most beneficial way of communicating your remote control to your robot? Are you going through a network? Are you doing it directly through Wi-Fi, or what's the media there?
Well, I bought some of those little things they call them, it's a LoRa, L-O-R-A, which stands for long range radio. And they're just little boards that do some kind of spread spectrum communication. And it's just a module you buy and you solder it down. And then you can get libraries to talk to it. And somehow the modules themselves are smart enough to talk to each other. So you get two of them on the same, I'm going to say the same frequency, but they don't seem to use frequencies. There's some magic. I think it's they pick a random pattern to change frequencies, and they can track each other. And somehow, to me, it's all magic. I don't know how that works, but I know if I get them and load the code, they tell me that I can get the things to talk to each other. And the benefit of that is that it's already got a lot of software built in there. So when I say, tell these two to connect, they start magically talking back and forth and doing various types of error correction and I don't know. I don't know exactly how elaborate these things are, but they seem to work fairly well. So what I have right now on the radio on the remote side, I just bought a single board from Adafruit that has a Cortex M0 microprocessor, and it's got one of those little radio modules on it. So it's like an Arduino that's got a radio. So I just simply bolted that into the box and gave it power. And then I've got the 4 joystick axes hooked up to the analog inputs, and I got various switches hooked up to digital inputs. So it has a loop that goes through, and there's like a 10 millisecond delay, and then it says read up all the switches and pack those into a single byte, read up the 4 analog inputs, and then I take all that stuff and build it into an 8-byte packet that I'm going to send across. And the reason I picked 8 bytes is because once it gets to the other end and I do a CAN interface has a maximum of 8 bytes it can transfer. So basically I just pack it up, and so I needed 4 bytes for the joysticks and 1 more byte for the switches. And so I said, well, I've got extra bytes left over. So the first byte I said make it a sequence number. So I just have an 8-bit number there. Every time I send a packet, I increment that. So the first byte that I send across gets incremented. And then I got my 4 joystick channels, and I got my switch channel, and I've got 2 more bytes left over that I could do whatever I wanted to with those. So essentially on the transmit side, it says read all the stuff up, says build that packet, and it calls the function that says transmit the data. And then after you do that, then the next thing says sit and wait for the receive data. So it magically takes that data and builds a packet and sends it out to the outside world and sits and waits for a response to come back. So at the receiver side says it's sitting there waiting for a message to come in. And once the 8-byte packet shows up, it hands it to me and I can do whatever I want with it. And then it turns around and creates a response packet and sends it back to the transmitter. So there's a 2-way handshake going on there. And I'm not sure exactly what you can do with that, but I did notice that one time I complained that it looked like the data was working, but it looked like it was pausing occasionally. And it turns out it's losing packets occasionally. It sends it and nobody acknowledges. And it doesn't seem to hurt anything. It's just that every once in a while it apparently drops a packet. And I don't know exactly what I should do about that. But that's just a way to get my bytes from one box to the other box. So then once it gets to the receiver, I get a call back saying, oh, we have data available. And I just say, go out and read 8 bytes, or maybe I say read it and it says, it tells me that it received 8 bytes. So at that point, I just strip off the data I want. And then I turn around, since I want to send it over a CAN interface, then I take those, I basically just take the 8 bytes it sent me and shove those into a CAN packet and call CAN transmit, and then it sends those out onto the CAN bus. Now, there's various things you could do there. Because I was just thinking, I was laying in bed this morning thinking about this, saying, how safe is this? And first of all, I think the fact that I'm using this type of radio makes it safer than if I just had a transmitter and just blatantly blasting bytes out into the ether with no response back. That's not really a good situation to get in. But here, since I'm using this, I think it's probably smart enough that it knows. It does know whether the packet made it or not, but I haven't done any kind of retries or anything. Basically, I'm saying the same data over and over, so I just let it fall through and do it again. And then also, it's got receive signal strength indicator at both ends, so it knows how strong the signal is, so you could watch that. And when I've got my packet of 8 bytes, I can put a CRC on that and send it across. So when it receives it at the other end, it says, I received 8 bytes, calculates the CRC and says, okay, that data is good or bad. And anywhere along the line, if I declare anything went wrong, I've got the option to just shut everything down at that point. Or I can say, well, I dropped a packet, but I haven't dropped more than 2 in a row or more than 1 in a row. So I'll just ignore that and continue on. And you can keep little counters that says, how many packets am I losing and how often do I lose those? And then the other thing is, in order to get my e-stop circuit to work on the transmitter, there's a e-stop switch. It's one of those red mushroom switches that goes up and down. And if you push down on that, it gives you one status. If you pull up on it, it gives you another status. So I stick those. I'm actually reading both sides of the switch. So I've got a high and low. Actually, I've got one is the complement of the other. So I stick that into my data. I send it across to the receiver. So the receiver says it has to be receiving data. And then it says it has to look at those 2 bits. And in order to turn on the e-stop relay, it has to have those 2 bits in the right combination. And if either one of those is not correct, then it shuts off the e-stop relay. So my thing will go into a shutdown condition. So if the thing is running, it works out really well. As I push the e-stop switch, the relay immediately comes on. As I lift it up, or when I lift it up, it comes on. When I push it, it turns off. But now what happens is the other condition you can have is that you lose the signal. Either too far away, or somebody drives between you, or your battery runs down and quits. So you need some way, because the way my code was originally set up, when you would lose the signal, and the easiest way is you just yank the power from the transmitter. And what would happen is my e-stop relay would stay on. It would stay active because my code said, look at the bits coming in and either set it or clear it. I had no bits coming in, so it would just, now I had a problem where if I yank off the battery, the thing would just keep going. So that'd be a problem. So I just put an extra timer in there that says, every time I receive a valid packet, I reset that to like 1 second. And then it's constantly counting down in the background. And if it reaches 0, then it shuts the relay off. So that's one thing that will, if I lose signal for whatever reason, it within whatever this timeout is, it shuts the thing off. So that's an added safety feature. But then I was thinking, well, since this relay is being controlled through this radio and 2 microprocessors somewhere along the line, something could still screw up there. And for some reason, I'm not, if my microprocessor on my receiver is not running at all, it can't turn that relay off. So I thought, well, maybe I could add some more smarts in there. One thing you do when you're dealing with microcontrollers is you put a watchdog timer in the software. And that's something where every so often you go ahead and you poke this thing and it says, okay, keep resetting it. And as long as you keep resetting it, everybody's happy. And if that ever times out, then you reset the processor, you pull the reset line and the processor starts over. So that's one way. If it loses its mind, you can reset the thing and hopefully it's going to come up and be running again. But I'm thinking, well, that still may not solve all my problems. So I thought, well, if I'd add a hardware watchdog timer. So if I'd add in between the relay and the radio, if I'd add something there that, again, like some kind of a timer, and I could use like a one-shot, basically a electronic timer that you have to, if you keep pulsing it, the thing stays active, and if you stop pulsing it, when it times out, then it shuts off. So I could have that. So the radio would be, every time it gets valid data coming in, it would toggle the pin on that the little timer. And if it ever stops receiving that data, because let's assume the microprocessor died for whatever reason, if it stops pulsing it, then that's going to time out and turn the relay off. So the more I think about it, there's more things I could put in there and get it to the point where it might be considered safe. I don't know. I'd have to, no matter what you come up with, somebody can say, well, what about this condition? Say, well, I don't know. We'll look into that, see what we can make it do. So, and when I started up this time, when I made that little video yesterday and ran my robot for 5 minutes, my robot has only run for 5 minutes so far in life. That's the first time I took it off a table and put it on the ground and fired it up. And I realized after I drove it around the yard 2 or 3 times that not once did I think, gee, if this thing quits, am I going to have to track it down and hit the e-stop switch on it? Because theoretically, e-stop switch in my hand on the remote, if I hit that should make it stop. But again, what if it doesn't? And I didn't think about it until it was all done that might have happened. It might have decided it was going to keep right on going, and I'd have to go chase it down and hit the switch to stop it. But it shouldn't be too hard to stop, because it's going to hit somebody's car and come to a stop. So I can run over and hit the switch at that point, but that's really not the best solution. So what was your original question? What kind of radios do I use? It's using that long-range radio, and there is some kind of protocols already built into it, and I'm not sure how safe they are, but they're safer than getting one of these little 433 megahertz transmitters that when you raise it high, it's putting out data. When you're not, it's not. If you start with something like that, you have to build up all the protocols and all the safety and everything on top of that. But at least starting with this, it's got some kind of bidirectional protocol built in. And if you wanted to do it over Wi-Fi, well, depending what version of Wi-Fi, if you use UDP, that's basically just a broadcast that says dump it out there and hope it works. But if you're running TCP protocol, then I think they claim that to be a guaranteed delivery, which means it tries to transmit a packet over your Ethernet or over your Wi-Fi, and if it doesn't get a result back, I think it keeps trying again. So I've just never had a lot of luck with Wi-Fi, and I'm not sure what kind of range you could get out of that to do something like this. The main reason I went this way is because Kyler said, "Oh, I'm here. Check out these little long-range radios. I'm using them. They work great." So that's what basically ran me down this line. I think on his, he just got a box with an e-stop switch and one of the radio modules. Then on his tractor, he's got another radio module to pick it up, and that's how he's running his e-stop on that. And the advantage I had, other than just rather than just put an e-stop switch, it lets me send all the analog information from joysticks, or I could put some pots on there with knobs, or whatever I want. It's essentially an Arduino that, as I said before, it's an Arduino with a radio on it. So whatever you can get the Arduino, whatever you program the Arduino to do, then you pack it up and send it over the radio, and it makes it to the other end. Well, one of the problems, and there's two problems I had. One, I bought two of those modules like in the remote control transmitter, and when I started hooking wires up to it, I realized I should have counted how many wires I needed to start with. So it's real tight on whether I have enough wires on the transmitter to hook up all. I need to put like 3 more push buttons on it, and maybe that's all I need is 3 more push buttons. That I was going to put some status LEDs, and that's chewing up my pins real quick, and I don't know if I have enough pins to do that. So I went out to the receiver side. I thought, okay, now I'm going to put a CAN interface on it. I looked at that board, and even though it's an ARM processor, it does not have a CAN peripheral built into it. So that was a problem. So I went back to Adafruit, and I bought their Teensy 3.2 and then an adapter board. So I put this radio onto the Teensy 3.2 with this adapter. And there's that one, that has a built-in CAN peripheral, so I can generate CAN messages. And the problem with the Teensy is the little board, the 3.2, it's got it's like a little Arduino with about 20 to 24 pins on it. And it turns out if you flip the board over and look at the bottom, they got square pads where you can solder more wires onto it. But unfortunately, I soldered mine down to the board, so I can't get to the bottom of the board anymore to get to those pins. So I got into trouble doing that too. So just little things. If I would have thought about it a little harder, it would have probably turned out a little better before I got this far.
I did buy one of the typical game controllers. So in my mind, I'm still trying to figure out how. I see Ross has packages for the game controllers, but I still haven't figured out how to get it from my hand out to the robot.
Well, Matt's doing that. How you got a short story on how to do that?
Yep, just through, so with Ross, you can connect multiple computers. So like on your laptop, you can plug your joystick into your laptop, run the joystick node, and then your laptop will be connected to your Raspberry Pi that's on your robot.
But what if my robot's half a mile away? What's the radio interference? That's what I was wondering how Jeff was dealing with that.
Yep.
The other problem I noticed this long range radio doesn't seem to be a high speed radio. So that's another problem, depending what kind of data you want to push across there. So it might even be good to have, say like that with your e-stop, you can get a good distance out of it, but it's just low speed data. And then you might want to have some other type of interface, either Wi-Fi, or some people will use the cell modems where you put a cell modem on your computer you've got in front of you and put one on your tractor, and then you go through the cell phone network to get data out there. And I think those are all high speed networks. It's just that you have to pay the phone company. You got two devices you have to get data plans on to be able to connect those together.
That's a pretty viable option though when you're going to be trying to get RTK over the internet too. If you're seeking to do that, it would catch both bases for you.
Yes, it would. Now, I don't know if it's as simple as 2 cell modems or if you have to talk to another base station somewhere. You might have to have somebody else go through a server somewhere so they both connect to the server. I don't know if you can. I think if you know the IP address, directly know it, and if you pay them more money, they'll give you a SIM card that has a static IP address. So from anywhere in the world, you know what the address is, and you can connect to your device. So, but that's something you'd have to look into and see what other people are doing, if that really does make sense to do that. And as far as how do you transmit over long distances, I don't know if anybody's really got a really good answer for that yet. Everybody keeps asking the question, but I don't know if anybody's come up with one that says, yeah, this is the way that works. You should do this, and it's going to work great for you.
So the GPS, the Ardu Simple, is that the name of the company? Aren't they using like XBee radios, or that's different than the MO radios were your LoRa radios, it's a whole different animal, isn't it?
They might be. I'm not sure what technology those use either. It might be the same technology. And it isn't clear to me if you buy two of these radios from two different companies, if they're going to talk to each other, or if it has to be the same brand and the same model for them to work. So it could be that those little S3DR radios, I think is what they call them, those might basically be the same type of radio, but I don't know. Anytime I see them listed, it seems like the distance is, they don't claim as far a distance on those. So I don't know if it's the same ones or not. And again, it's good to go out on the internet and see what, find one you think you might want to use, and then go out and see what people are saying and see if they've run any kind of range checks on it. And because if you get enough people doing checks, then you find out that, if one guy claims it works great, and somebody else says no, it's just crap. Then you gotta find at least a third person to clarify one way or the other on that. And back to the comment, do you want to have a joystick and you want to be driving your tractor quite some distance away? The other thing to consider is the less data you're sending back and forth, you're probably going to be better off. You don't want to have two computers running a full ROS connection between them if you don't have to. If your tractor is smart enough to say, I want you to drive up and down this row, and if you run into anything, or I shouldn't say run into it, if you encounter an obstacle, you should come to a stop and just send me a message saying, hey, I'm stopped. And then you can decide what to do with it, rather than pushing all the traffic back and forth, because that right there is going to get you into trouble if you're trying to push too much data, because then you have to have a high-speed link to make that work. But if you get to the point where the thing is smart enough to do what it needs to do, and it's just up to you to say, okay, go off and do your job. And if it has a problem, says, okay, I've got a problem. That'd be one way around that. Or in my opinion, I like to, it's gonna be a long time until I just simply turn mine loose and go take a nap or go away. But if you ask Kyler, I think he tends to just turn his loose and not pay attention to him. And that, I still don't like that concept. But it's up to the individual, I guess.
What amazed me, Jeff, was that when we had our thing running in autonomous right at the start, and so we run it on an industrial remote control. It's an Ikuzi out of Spain, which I think actually Danfoss have bought, but we run that, and it's terribly sluggish. We're looking at 700-800 milliseconds of time lapse before we actually get a response to the command. It's terrible, but it's remarkable how blasé you get. Talking about Kyler, we were only running this thing for a couple of days, and it's for maybe 300 meters away, and we're having a conversation between ourselves and going, oh shit, that's right. Where's that robot? It's crazy. You just I don't know whether you get the confidence in it or whether it's, I don't know what it is, but it's scary when you look back, a couple of seconds and it's gone, and you go, okay, well, we know it's going to come back, don't we? Please say yes.
Well, we had an even worse problem than that, because ours was set up so you had to have the remote control turned on and you had to start it from the remote control. But then somebody would lay the thing on the ground and go walking around and say, oh, there's a problem. Where's the remote control? Because they'd have no idea where it was. So that's yet another problem where if you have something on there where you have to hold your finger on it the whole time, some kind of a dead man switch, that's one way around it. But then that's real tiring to do that. As you say, you get into a conversation, or I think Kyler's story was the first time he lost a tractor, he says, okay, go in that direction. He'd say, go north. And he's sitting there in his truck writing software, and he thought, where's my tractor? And it had gone through a fence onto his neighbor's property, and he had to go track it down. He said his neighbor wasn't too happy about that. So I maybe thought about it a little harder after that. But it seems to me that, have you done anything with a geofence on your your vehicle at this point with the GPS.
Yeah.
Because you've got the GPS there. It's going to be free. In fact, the U-Blocks even has some kind, you can program it in. It's got a pin coming out saying you've exceeded your range. Or if nothing else, just have something that's reading your position. If it gets outside your rectangle, it automatically stops the thing. Because you basically get that for free. And that way, if you aren't paying attention and it goes too far, it'll at least contain it to whatever property you tell it, whatever's programmed in. Assuming you've got it programmed in right, that's yet another issue.
Yeah, you'd probably want to test that.
Great. Looks like we're at the top of the hour, a little over, but thanks for being here. Jim, good luck on setting up in Sturgis next week. Stay out of trouble. Hope to see you next Tuesday, huh? Or after when you get out.
Watch out for those hot naked girls, Jim.
Yeah. Yeah. We'll talk to you next week.
Okay, see you.
Mhm.
Thanks. Bye.